Hello and welcome, class. Today we are going to be predicting decomposition reactions, which is the second of 5 reaction types that you're going to encounter in chemistry. So let's get to this. Decomposition reactions only have one reactant, means one thing before the arrow, and that's it. We're going to be focusing on decomposing carbonates, which is a very common decomposition done in chemistry at the high school level. So I'm going to be dealing with the decomposition of silver carbonate. Now, whenever we are dealing with this sort of thing, we want to check our charges. Carbonate always has a charge of 2 negative. You can see that right down here where it says cancel the charges. So we already know what one of them is going to be. If I look up on the periodic table, I see silver is a 1 plus charge, which when we go with our 2 negative charge from carbonate means we are going to need a second silver. Now this is very important is because carbonates all have a very consistent charge setup. You'll see that as we go. So I'm going to need 2 silvers for 1 carbonate. We need to keep that in mind as we move on. Silver is of course Ag, and I'm going to need 2 of them. So Ag, and I'm going to give some space for our carbonates. So here we've got silver 2 and carbonate. Now it is going to decompose into carbon dioxide. So the first thing I want to do is I want to put my CO2 there. Capital C, capital O, and a little 2. Now, we then are going to have a metal oxide product. And when we have that metal oxide product, we are going to need to make sure that it has the same setup as our silver carbonate, meaning we had 2 silvers for 1 carbonate, so we are going to have 2 silvers for 1 oxide. This is because both carbonate and oxide have the same charge, which is a 2 negative charge. So this is going to be Ag2O. Now the nice thing about decomposing carbonates is most of the time they are already balanced, so there's not much that we have to worry about there. So that was the decomposition of silver carbonate, an easy carbonate to decompose. Let's go look at something that's a little trickier. We are going to look at the decomposition now, not of silver carbonate, but we are going to look at the decomposition of thorium carbonate. Thorium carbonate will be the one that we do next. Now, thorium is a heavy, often radioactive metal that has a 4 plus charge. So when we're dealing with our charges, which we're basically doing at the beginning when it comes to one of these decompositions, we are dealing with the charge of 4 plus going to a charge of 2 negative. So 4 plus going into 2 negative, which means we are going to need a second carbonate in order to cancel that out. So that's going to wind up making something that's going to be very interesting looking when we type it out. Because we're going to have TH for our carbonate, and then we're going to need to have our carbonate of CO3. We're going to need 2 of them when it's all said and done. Then we're going to get our products. Our first product is going to be the CO2, just like we had normally, and I'm going to set this up like so, with just a little bit of space. Now, carbon dioxide, of course, is CO2, which I'm going to leave there. Now, again, for this, I am putting my subscripts in line. They really should be below, but I'm just using paint real quick to make my life easier. Thorium carbonate would be 1 thorium, and just where it had 2 carbonates, we're going to have 2 oxides. So earlier when we did this, you may have noticed that there were 2 carbonates. Well, that also means we're going to have 2 oxides. And not only are we going to have 2 carbonates and 2 oxides, but when we balance it, we're also going to need to have 2 carbon dioxides. And that will cancel out the rest of our oxygens, and it will cancel out our carbons. So that's how that goes. The number of carbonates equals the number of oxygens, and it equals the number of carbon dioxides. So that was thorium carbonate, which is our second of the decompositions. You're now going to see our third and final decomposition. This decomposition is a decomposition of Technet Im7 Carbonate. So we're getting ourselves a very highly charged compound to work with. Now, when we're dealing with charges here, we're dealing with the fact that technetium has a 7+ charge, and carbonates has a 2 negative charge. So what I'm going to need to do is I'm going to need to make these both into 14. So that means the 7 is going to get 2 of them, and the 2 is going to get 7 of them. So you can think of this like crisscrossing, which is something we talked about in the making ions section. So we're going to have technetium, and we're going to have our carbonate, and our technetium is going to get our 2, and our carbonate is going to get our 7, like so. So the technetium gets the 2, the carbonate gets the 7. That makes them both into 14, which is what we want. That is going to cancel it out, and then we're going to move on to our products. For our products here, we are going to wind up with our CO2 as our first product, and our second product is going to be that metal oxide, which is going to be Technet Im7 oxide. So just like we did before, we are going to see that patterns for decompositions are pretty stable. There's going to be 2 technetiums, and there's going to be 7 oxygens. So that makes it so that we now have our compound set. But then we look at this and we go, oh my god, this might be really hard to balance. But it's not. The trick is still the same. The number of carbonates set the number of pretty much everything. So the fact that there is 7 carbonates here meant that there was 7 oxygens here, and what it's also going to give us is 7 carbon dioxides. And when we put those 7 carbon dioxides where it's supposed to go, we will see that there is 2 technetiums on both sides, the reactants and the products, 7 carbons on the reactants, 7 carbons on the products, and then when we count them up, there's going to be 21 oxygens in the reactants. 7 times 2 is 14, but if we add the other 7, that makes it 21, so 21 on both sides, and all we have to do next is get rid of our charges, because we should not have charges in our final answer. And that's it. Decomposition reactions. I gave you an easy one, a tricky one, and a truly difficult one. They all have the same pattern. Good luck, students. Take care and stay safe.